welcome back to our YouTube channel, Becoming a ROS Developer. My name is Rodrigo, and today we have one of our students, Hei, who has completed the course ROS Basics in 5 days. This is an online course we offer, and at the end of this course, you can actually present a project that is implemented on a real robot here at the construct. So that's what we're going to be seeing here today. So hello, Hei, how are you?
I'm good. How are you?
I am great. I am very excited to see what you've done with your project. So whenever you're ready, please share your screen and show us.
Sure.
Great, we can see your screen now.
Okay. Yes, I would like to show the final result before I presenting.
Great.
Yeah, as we can see, the robot now is turning to the wall it found,
Uh-huh.
and then it will turn again to make the right-hand side detection to the wall, and then it will start following the wall. Meanwhile, I would like to also show the action.
Uh-huh.
So that we can see that when the robot is moving, the total distance traveled is keep updating. And
Right.
also here we can see a few message like at the start, wall found, moving to the wall, um, and then wall arrive, wait for the SQL server, and then now it is start wall following.
Uh-huh. Uh-huh. Great. Awesome.
And I will also start the seeing the result.
So it's going to do one lap and then stop?
I didn't set it to stop, but it will conclude, complete the action process, but the robot will still
I
keep
see.
going.
I see. Cool.
Actually, I also tried to set it to stop. It also worked, but as the question didn't say that I have to stop it after one complete lap, so I keep it going.
No, you don't need to. I was just curious.
Yeah.
So we know when it ends, right? So it's supposed to do the
Yes.
one lap, and then when it arrives
Yes.
to the same point, we should see that list
Yes.
appear, right?
Yes. And I also will have a message pop up here that
Mm,
saying
mm,
that
mm.
the robot have completed a lap.
Right.
And I didn't prioritize the running speed of the whole process because it is not the goal, one of the goal of this
I'm sorry.
project.
Say
So
that again.
I didn't prioritize of the running speed
Oh, don't worry.
because
Don't
the
worry.
goal it's not a one of the goal. Yes,
No, no,
and
it's not.
after it arrives somewhere here, it will say that it complete the full lap,
Ah, yes.
and then we can see the list of the raw data.
What is that data?
It's the odometry data.
Uh huh.
Same as the question say when it complete the full lap, the result of the result should publish the full list of data.
Mm-hmm. Mm-hmm.
Yes, I think that conclude my demonstration here.
That's great. Awesome.
Then I will stop it and then start explaining my logic.
Please.
Okay. The project is divided into three parts. The first part is the wall following. which allows the robot to move along different walls. And then the second part is finding wall, which means the robot have to locate a wall and navigate itself to that wall. And the last part is recording odometry, which means it's just simply recording the raw data of the odometry and also calculating the accumulated travel distance of the robot. And also at the end, you have to publish the um, final list of the odometry raw data when the action complete. So now I will go into the detail of my project logic. I would say the main script will be the raw following script. It contains the logic of raw following, and also it acts as the client of the service and the action.
Mm-hmm.
In this script, the first big step to do is to call the found raw service by sending a request message. Then we can go to the found raw server here. When I launch the main launch file, both action server and the service server are start at that time. And then when the request message is received by the server, it will perform two main steps here. The first main step is the confirm wall, and the second step is go to wall. And I will explain the confirm wall, the logic here by showing one of my graphic here. We can see that in this example, the robot is right here. It may detect a lot of different things. But I will start the process with finding the closest detection. Like for
Mm-hmm.
example here, this one is the closest detection. It will compare two pairs of adjacent detection in the pattern of mirror, like this. If the detection is on the irregular shape, it will probably will not result in the same reading values. So I would say this is not a wall, so that it will go to the second closest detection. Here shows the four detection that I chose. Then like this, the second close detection is here, and then I also compare two pairs of detection, and then if both pairs fall within the threshold value, and I'm confident to say this is a wall, then I will pop a message saying wall is found, and then the robot will complete this detection step, and then go back and then go to the next step is by popping a message moving to wall, and then perform the go to wall step. Here is this is the go to wall step. It is simply just um, first by according to the detection direction, then it will turn the front distance until the front distance match with the previous detection measurement. Then it will stop the rotation. The robot will go forward until it is less than 0.3 meter from the wall, which is a stay in the question. Then it will stop moving and then turn again until the right side detection is matched with the previous detection.
Mm-hmm.
Then it will stop rotating, and the whole process of this service will be concluded as finished. Then it will send a message as a response back to the main script. After that, is the response is true, then the message was arrived will pop up, and then I will send a go message to the action server. Meanwhile, I will enable the wall following feature, which is the logic is stated in this script as well. Then the robot will start the wall following feature, and then also the action server start. I will first explain about my action server
Mm-hmm.
here. It is quite simple. It is just try to record. It did two things. The first thing is to record the current position, save it and then for the next time frame, I will record the current positions again, calculate um, the linear distance the robot has traveled, and then accumulating for each time step, so that I can have the total travel distance of the robot. Then um, then I have implement logic here for complete lab detection. It consists of two things. When the robot is just a start, it is not travel for a certain distance. The loop will still keep going. And then when the robot is travel far away, and then it will try to compare of the starting position and the current position. If it fall within the threshold value, I will consider it to be a complete lab, and then it will go to the second part of this action server, which is going to show the result of the raw data of odometry, and also set the status of this action as succeed.
Mm-hmm. All right.
Then I will yes, and meanwhile I have mentioned that the wall following feature is also happening here. So I will also talk about my logic of following the wall. And then I will use a graphic here to explain it. The question state, I have to make the robot to stay within 0.2 meter and 0.3 meter, which is the red straight region here. Then I have implement a proportional controller for doing this process. The robot, when the robot is outside of the 0.2 or 0.3 meter, it will calculate its error by its position, from its position to the center line, which is 0.25 meters. And then the formula is stated here, which is the proportional gain times the error, which will be the resultant angular velocity for it to turn back to the correct position. Then the rationale behind of this error calculation, instead of just calculating the robot current position with the edge of the wet area, is because I would like to have a relatively great enough values once the robot have exit the region, instead of just having a small error, because for a controller it will tend to minimize the error. If I only minimize the small error here, the robot will tend to stay at the edge, always stay at the edge of the area. So I used the center line for calculating the error. Then when the robot, the front detection is less than 0.5, it will just simply turn left. And then for the rest of the time, when the robot is staying within the red area, it will just keep going forward. Then the last part is I will keep checking the state of the action server, and if it is if the state is turned to succeed, and I will pop the message is called complete a full lab, and also I can also have an option to stop the robot or not, but for now I have set it to just keep continue running. But I will conclude the action is complete, and then show the full list of the result of the odometry data.
Mm-hmm.
And I think this is the complete logic of my project.
Awesome. Well, first of all, let me tell you, Kinhei, congratulations. A very nice project. Let me tell you a couple things I really liked about it. First of all, your filter to identify whether or not it is a wall that you're looking at. I thought it was very simple and elegant. That's really nice to see, and the graphics made it really easy to understand. So I thought that was great, and I also liked the implementation of that PID proportional controller to control the movement. I thought that was an extra step that you took that was really nice, and it showed. And the last thing I was really impressed by is how uh, sound your logic was and how concise your code was. It looked very organized, and it also shows that you took a lot of time and effort into this project because of the practice that you can tell us behind it. Even at at the point of opening your terminals and inspecting things like that. So those are things I really liked. And
Thank you.
let me ask you. I have one question really about your your project, and it's on this filter of wall versus obstacles, irregular shape versus not uh, uh, situation. And so my question is, what if when you are looking for this wall, you are oriented to the wall in such a way that the rays that you are comparing are too different, right? So the one on the left, let's say you're oriented very, so let's say your robot is right here and it's looking at it this way. So this ray is going to be way shorter than that ray, than the, so how does that account for that, or would it think that it's not a wall?
Um, okay, maybe I will share my screen on the graph again.
Yeah, yeah. Yes.
Maybe I assume if the robot is right here, like you have just mentioned, you have
Uh-huh.
did you say that if a way is this direction, then I cannot find a wall, right?
Yeah,
Something
let's
like
say,
is it?
and then the other one would be very different compared to that one. Yeah, not very, but
I
might.
in this case I will assume maybe I start with the shortest distance. If this is not okay, uh, like what you have said, then it will move to the next direction. Even if it's a wall, even
Uh-huh.
it should be detected, and then I would keep moving. If the robot is here, maybe it end up finding some detection is it's a wall is quite far away. Then it will still I hope it will still works and go to that wall,
I
no
see.
matter
Great.
where the robot it was.
Okay, so
But
even
of course, I also of course have a sign up here. I have also implement that a statement. No wall has been found. The code it will still work. It will not bug or crash
oh,
somehow.
nice,
And
nice.
one more sign up is I have also tried to experiment by placing the robot like at the middle between some obstacles, and it will still go. It will still have a chance to successfully go to the wall right here.
That's great. That's great. So basically, even if it misses one reading and it thinks the wall for whatever reason is an obstacle, then the next one will be better suited and it'll go to it. That's a great solution. That's
Yes.
awesome. Um, well, that was really my only question, because other than that, everything was so clear and greatly accomplished. So I just want to congratulate you again, Kinhei, and
Okay.
thank you for.
I would like to add one more sign up on this project.
Mm-hmm.
I have. Oh, sorry. I would like to share my screen
Yes,
again. Sorry.
yes.
Okay. Yes, for the controlling over here, because the question asked me to keep only trigger the control logic at this outside of this region.
Mm-hmm.
I have also been thinking that if I calculating the no, I mean the triggering of the controlling only at the 0.25, the performance will be even better because I could avoid this zigzag movement path.
Uh-huh.
Yeah, this is my final note.
That's a good idea. Yes, yes. There's always a thousand different ways of keeping improving that, and I love that you mentioned that, because again, it shows that you've taken something out of our course. So congratulations, Kinhei. Really, really nice
Thank you. Thank you.
presentation.
Thank you.
And all right, great. So let me just switch back to my camera. And yes, guys, this is what you can do if you take one of our courses that offers a certificate. You can come here and do a presentation of what you've learned on our course through the project on a real robot. So I invite everyone else that is watching today to do what Kinhei did here and come show us your projects. And that is it for us, guys. We'll see you next time for our next presentation.